Hello. Okay, yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And we are still doing some questions from the acids and bases. And here comes one of the questions. It says, give a reason for each of the following. Okay, the first one, ethanoic acid is classified as a weak acid. What is the reason for ethanoic acid to be classified as a weak acid? Okay, you have to know that strength of the acid. Strength means being classified as weak or strong is based on the degree of ionization. Strong acids are fully ionized and weak acids are partially ionized. So there lies the answer. Why do we say ethanoic acid is a weak acid? It is partially ionized. Thank you. Okay. Then comes another question. Give a reason why nitric acid is a monoprotic. Okay, you have to know that this one is based on the number of moles of hydronium ions released by one molecule or by one mole of the acid. So monoprotic, during ionization, 1 mole of the acid release 1 mole of hydronium ion. Diprotic, 1 mole of the acid release 2 moles of hydronium ion. So like that. And there lies the answer. What is it? It is monoprotic because 1 mole of nitric acid release 1 mole of hydronium ion during ionization. Thank you. Okay, there comes the next question. It says, give a reason why sulfuric acid is a strong acid. We say, the strength of the acid is dependent on the degree of ionization. So sulfuric acid is fully or completely ionized. That's the reason why it is classified as a strong acid. Yes, then comes this question. It says, to determine the percentage of ethanoic acid in the vinegar, it was found that 40 cubic decimeter of 0.45 moles per cubic decimeter of sodium hydroxide is needed to neutralize 20 cubic decimeter of vinegar. So the first question comes, calculate the pH of sodium hydroxide. Okay, so in this case, we have to remember that pH is equal to negative log hydronium ion concentration. Now you have to remember that we are now talking about sodium hydroxide, which is a donor of OH. And this one says it must be hydronium ion. So what do? We apply our KW to help us solve that problem. It says KW is equal to the product of these two. And KW is known, is 1 times 10 power minus 14. We are looking for hydronium ions, but we know because 1 mole of sodium hydroxide donates 1 mole of OH. So we are going to take this one as the concentration of OH. And remember, we are dealing with the sodium hydroxide, which is a strong base. Strong base is fully ionized. Fully ionized means the number of moles of the base are equal to the number of moles of the hydroxide ion. So what do we have here? 0.45, because the concentration remains the same as that of the hydroxide ions. So from here, we compute hydronium ions. So this is what we get. The concentration of hydronium ion is 2.22 times 10 power minus 14. So after getting it, what do? We substitute it in that equation. We substitute this there. Okay, so what do we say? It is pH equals to negative log 2.22 times 10 power minus 14. And what do we get? Let's check what we get. Okay. Then comes this question, 5.22. It says, calculate the percentage of ethanoic acid by mass in the vinegar. How do we do this? They said 1 cubic decimeter of vinegar is equal to 1 gram. Okay, what do we do? Like always, we are going to use a stoichiometric approach. We're having a reaction. The reaction is between ethanoic acid and sodium hydroxide, giving you and water. Okay, that is the reaction. You have to earmark that our interest is how these ones are interacting. So if that's the case, we are going to divide this one into 2. Okay, this side we are going to have ethanoic acid. That side we are going to have sodium hydroxide. The ratio is 1 to 1. And from what we see here, remember we have to move from known to unknown. What is our known? It is sodium hydroxide. We have both. You have the concentration, which is 0.45 moles per cubic decimeter. You have the volume, which is 40 divided by 1000. To change it to cubic decimeter, you get 0.04 cubic decimeter. After, when you get those two, it gives you a number of moles from this formula. Okay, then what is concentration? 0.45. N is wanted, but the volume is 0.04. So from here, what is our N? Let us find out. So we get the number of moles of sodium hydroxide which reacted. But you have to recall that the ratio is 1:1. So in other words, if you go that side and you have to tell the number of moles of ethanoic acid, it is this one because the ratio is 1:1. So it's going to be 0.018 moles. Okay. So now we know the number of moles of ethanoic acid. What do we do? You convert these moles to mass using what formula? Using N is equal to M over molar mass. So our N is 0.018. Our mass is wanted, and the molar mass for ethanoic acid is 60. So from here, what do we get? You have our mass. That's the mass of ethanoic acid. So let's have it. So we have the mass. We have the mass of ethanoic acid. So after that, what do you have to perform? To mass of ethanoic acid over mass of vinegar times 100. You have to recall that 1 cubic decimeter of vinegar is equal to 1 gram. So what do we have here? Remember, how much vinegar do you have? We have 20 cubic decimeter. So under the circumstance, what do we say? If 20 cubic decimeter of vinegar will give you 20 grams. So we know the mass of vinegar. So what do we get here? We are going to say, what is the mass of ethanoic acid? 1.08 divided by what? By 20 times what? Times 100. Okay. What do you get as your answer? Let us compute and see. So we come up with this percentage. So the percentage of ethanoic acid in vinegar is 5.4%.